my electricity project. So for the electrical circuit components I used were the light dependent resistor, the capacitor, a 10K resistor, a light emitting diode, and a switch that turns it on or off. This is the light dependent resistor. So the light goes in here in the middle part, and the resistance varies based off the input of the light. So it's very useful in electronics and just having the screen light up when you're outside. So the project I did was a LDR with a LED, and it shows the variation in brightness varied by the amount of light that goes into the LDR. I selected this for my project since I would like to show how this technology works. What it does is it adjusts the brightness of the display based off ambient light levels. The second component I used was a capacitor. These capacitors are used to store an electrical charge when the whole unit is de-energized and allows for surge protections, and they're commonly used in a lot of electronics. For mine, I use mine just as a way so you could see the light diminishing when you turn off the power off the switch. So I thought that was kind of cool. I also use a 10K resistor. So a common type of resistor used in electronic circuits for various purposes such as current limiting, voltage division, or biasing. I use mine as a current limiting. Next, we have the light emitting diode. This is a semiconductor device that emits light when an electric current passes through it. These are very widely used in various applications, including light displays, indicators. And I didn't know that they had just barely invented the blue LED maybe like 30 years ago. So I thought that was kind of cool. And it makes sense that they're coming out with a lot of new LED technology because of the way that they've barely actually found the technology. So I thought that was kind of cool. I also used the on-off switch on the ground side. That way I could cut the power. And I like to use this so I could just play around with the circuit and I could just make sure that it's on or off. So this piece right here is one of the most fundamental components in an electrical and electronic system, and it is used to control the flow of electricity to various devices or components. But like I said, I use mine as a kill switch, meaning I can cut the power from the breadboard while the main power on the power supply is still on. I thought that was kind of cool. This is just a miscellaneous wire I used for the ground, just in my kit. I try to use mostly everything I had in the kit because I didn't want to go and, you know, buy anything. So this is my schematics for the circuit. So we start off with the 5 volts on the positive side. It goes up through the LDR, the light dependent resistor, goes through this split and it connects to the capacitor. connects to the R1, the 10K resistor, and then it goes to the LED connected into that same splice. And coming out of it, you find yourself with the switch on the ground side, and that's how I'm able to turn it on and off and use it as a kill switch, even though there's power to the 5 volts on the main breadboard. And here's some pictures of it on and off. The top one is with it on and just my room light. So that's how bright it was with my just the light above me. If I were to use a light closer to it, it would light up brighter. It would get brighter. And so I used the transistor so when I shut it off, I was able to see it fading away slowly. So the bottom picture in this one, you can see I had the kill switch on, so there was no power to it even though the light was on. So once that light hits the LDR, the LED will get brighter, like on your phone when you set to automatic screen brightness. When you walk from inside to the outside, like on those days when it's really bright and you look down and you can't see anything on your phone, this technology is what helps it light up without you doing anything. So this is the main video of the circuit working in action. I just thought it was a fun way to engage with the components and visually see the effects of the capacitor and the LDR in real time. Then here I am just playing with the amount of light that goes over the receptors. You can see that when I put my finger over it, the LED turns less brighter. I'm about to hit the kill switch right now, and you'll see that the light to the main breadboard is still on. The power is still on that side, but on this side, I keep cutting it on and off. And you can see the capacitor working as well because of the way the light fades slowly. So I just thought this was really cool, and overall, I really enjoyed this project. It helped me see that circuits are easy and they're not that complicated. You just have to put in the work and actually want the circuit to work because you can get pretty angry pretty quick and just not want to do the project. So I chose this circuit setup after I noticed that my phone wouldn't light up anymore and I had a big crack on the LDR. I wanted to show how this type of resistor worked and how it applies to everyday electronics. From this project, I learned that it's hard to keep track of all the small parts in a circuit. Another thing I learned was that the components must be connected properly or else it won't work. Some of the things that I tried was putting 3 LEDs and having one set in series and the other in parallel, like the lighting system in your car. I liked the way it was coming out, but I thought that more people will relate to the phone example. So that's why I decided to use that one instead. But thank you.